Your 7.3-liter Power-Stroke diesel has factory features and designed-in parameters that are actively accelerating its own destruction. Most owners have no idea that the very truck they praise for its million-mile reputation is constantly fighting against engineered inefficiencies and outdated corporate logic that Ford locked in place decades ago. You think you're treating that unkillable cast iron block right by following the book, but the factory manual is a blueprint for premature wear. Manufacturers build vehicles to survive the warranty period, not to last forever, and the 7.3 is no exception. Today, I am exposing 5 factory settings and engineering choices that are damaging your truck without you knowing. Setting number 3 has caused more catastrophic mid-highway breakdowns than almost any other sensor failure in diesel history. And setting number 1 is so deceptive that owners actually think it is beneficial to their engine when it is doing the exact opposite. Let's get into it. Number 5. The factory oil change interval and high shear injection pressure setting. Number 5 is Ford's factory recommended 5,000 to 7,500 mile oil change interval, a standard maintenance setting that is quietly grinding your engine bearings to dust. Ford marketed this interval as a convenience feature to lower the cost of ownership, claiming the massive 15-quart oil capacity could easily handle the mileage. But here is what Ford doesn't tell you. They treated the 7.3 like a traditional mechanical diesel, completely downplaying the brutal reality of the HEUI injection system. As a technician who has pulled hundreds of oil samples from these exact trucks, I can tell you that the mechanical reality inside that block is a war zone. The hydraulic electronic unit injector system doesn't just use oil for lubrication, it uses it as a hydraulic fluid. The high-pressure oil pump, or HPOP, forces that engine oil through tight tolerances at pressures reaching up to 3,000 psi, shearing the fluid molecules apart. By the time that oil hits 3,500 miles of use, its viscosity has been completely chopped down. A standard 15W40 oil is routinely sheared down to a flimsy 30 weight or even a 20 weight fluid. When you leave that sheared oil in your crankcase for the full factory recommend interval, your engine is starving for protection. At 200 degrees Fahrenheit, that thinned-out oil cannot maintain a sufficient hydrodynamic film barrier between your crankshaft and your rod bearings. Every time you lug that truck up a hill with a heavy trailer, you are creating metal-on-metal contact. The damage is cumulative and completely invisible until it's catastrophic. I have personally inspected rod bearings from trucks run strictly on Ford's 5,000-mile schedule, and they are consistently worn down to the copper overlay long before their time. The solution is a simple change in behavior, not a fancy aftermarket purchase. Stop listening to the 1990s manual. Flush that oil out every 3,000 to 3,500 miles max, or switch to a high-quality full synthetic heavy-duty diesel oil that resists shear degradation. If you keep running conventional fluid to the factory limit, you are actively sacrificing your engine's bottom end to corporate marketing claims. Number 4. The delayed glow plug control cycle setting 4 is one that Ford engineered into the powertrain control module to improve cold weather startup reliability, but under daily operating conditions. It is creating the exact environment that destroys your battery banks and burns out your electrical system. When you turn the key on a 7.3 Power-Stroke, the wait to start light illuminates on your dash. Ford's documentation implies that when that light goes out, the glow plug cycle is finished and the engine is ready. This is a complete corporate fabrication designed to make the truck feel as fast starting as a gasoline engine. The hidden mechanism inside the PCM tells a completely different story. The computer actually commands the glow plug relay to keep sending maximum amperage to all 8 glow plugs for up to 2 full minutes after the engine has already started, regardless of whether that dashboard light is on or off. Each individual glow plug draws roughly 10 to 15 amps. When you multiply that by 8, you have a massive 80 to 120 amp continuous draw pulling directly from your dual batteries and dragging down your alternator the exact moment you fire the truck up. The consequence of this factory setting is a hidden financial drain on your wallet. Because owners don't know the plugs are still glowing, they immediately turn on their heater fan, their headlights, and their radio right after startup. This creates a severe electrical overload. The factory alternator, which is only rated for a modest 110 amps on most configurations, cannot keep up with a 100 amp glow plug draw plus the vehicle's running gear. It forces the alternator to run at 100% capacity while outputting low voltage, cooking your alternator internal diodes, and keeping your expensive dual batteries in a constant state of undercharge. This is why 7.3 owners complain about replacing batteries every 2 years. To fix this, you don't need to rewire your truck or buy a manual override switch. You just need to change how you drive it. Get an inexpensive digital voltage monitor that plugs into your cigarette lighter. When you start the truck, watch that voltage display. It will sit low, around 11 to 12 volts, while the PCM keeps those glow plugs active. Wait 90 seconds to 2 minutes until you see that voltage suddenly jump up to 13.8 or 14.2 volts. That jump is your signal that the factory glow plug cycle has finally shut off and your alternator is now free to charge. Do not load down the electrical system with accessories until that voltage jump occurs. Your alternator and your batteries will thank you. We've already uncovered how Ford's baseline maintenance intervals and hidden electrical cycles are quietly undermining your truck's longevity from the moment you turn the key. But as we move deeper into this countdown, the factory settings shift from basic inefficiencies to outright engineering traps that actively induce mechanical failure. Number 3. The blind CPS logic and the cylinder number 8 contribution error setting. Number 3 is the factory powertrain control module calibration for the camshaft position sensor, a programming oversight that has caused more sudden, mid-highway breakdowns and hidden engine misfires than any other single component on this platform. Ford designed the PCM to rely entirely on this one fragile Hall effect sensor to calculate engine speed and position. If the PCM loses that signal for even a millisecond, it drops all injector firing commands instantly. But the real damage isn't just the famous roadside stalling. It's a hidden cylinder balancing error built right into the factory software logic. Here is the mechanical reality under the hood. In an effort to solve a distinct engine noise and rough idle complaint in the late 1990s, Ford introduced a specialized long lead injector, known as the AE code injector, specifically for cylinder number 8. The factory PCM logic was modified to alter the timing and fuel delivery pulse width for this single cylinder to compensate for fuel pressure drops at the end of the dead-headed fuel rail. However, Ford paired this mechanical band-aid with an incredibly unrefined CPS diagnostic setting. The PCM constantly monitors the rotational speed of the crankshaft to check if every cylinder is contributing equally. But the factory sensitivity threshold is calibrated so poorly that it completely misinterprets the firing event of cylinder number 8. The consequence of this blind logic is a slow, rhythmic beating that punishes your engine's rotational assembly. Because the factory programming cannot accurately read the contribution of that AE injector against the standard AD injectors in the other 7 cylinders, the PCM constantly overcorrects or undercorrects fuel delivery to the back of the engine. I have hooked up professional diagnostic equipment to hundreds of bone stock 7.3s, and they almost always show a hidden, perpetual cylinder contribution fault on number 8. This creates a severe, unnoticeable power imbalance across the crankshaft. At 2,000 RPM under heavy towing loads, this imbalance translates into a destructive harmonic vibration. It beats up your dual-mass flywheel, wears out your main bearings prematurely, and forces the engine to run rougher than it ever was designed to. The solution doesn't require you to rip your fuel system apart. First, throw away any cheap auto parts store replacement sensors. The factory logic is highly sensitive to the voltage thresholds of the sensor itself. Aftermarket units have the wrong internal resistance and make the cylinder imbalance significantly worse. You must run a genuine Motorcraft gray or dark blue updated sensor. Second, if you want to permanently fix the underlying engineering flaw, skip the factory software configurations altogether and install a mechanical fuel crossover line, a regulated return system, to equalize fuel pressure to the back of the cylinder heads. This fixes the physical pressure drop, allowing you to drop the factory AE injector logic entirely and restore perfect, balanced harmony to your internal rotating assembly. Number 2. The factory automatic transmission shift strategy and torque converter lockup calibration setting number 2 is one that Ford marketed as a premium comfort and fuel-saving feature, but under real-world towing conditions, it acts as a direct wrecking ball to your automatic transmission. On both the E4OD and the 4R100 4-speed automatics, Ford programmed the transmission control strategy to prioritize smooth, passenger car-like shifts and early torque converter lockup. The factory calibration is explicitly set to keep engine RPMs as low as possible during light to medium acceleration to satisfy EPA drive cycle fuel economy testing. But when you analyze the fluid dynamics inside that transmission casing, you see a completely different, destructive reality. To achieve those seamless, unnoticeable gear changes that suburban buyers wanted, Ford engineered a prolonged clutch slip into the shift execution. Instead of snapping firmly into the next gear, the transmission slowly applies hydraulic pressure to the internal clutch packs, dragging the friction plates across one another to damp out the shift feel. Furthermore, the factory PCM settings command the torque converter clutch to lock up at speeds as low as 35 miles per hour, while the truck is still in third gear, lugging the engine down to a meager 1,200 RPM. When you haul a heavy load with this factory shift strategy active, you are cooking your transmission from the inside out. Slipping the clutches to create a smooth shift generates an immense amount of localized friction heat. At the same time, locking the torque converter too early at low RPM drastically reduces the spinning speed of the transmission fluid pump, which is directly driven by engine speed. You are simultaneously creating maximum heat while operating the internal cooling circuits at minimum efficiency. I have pulled apart factory 4R100 transmissions where the fluid was completely charred, and the internal clutch linings were stripped down to the bare steel plates, not because the owner exceeded the towing capacity, but because the factory programming literally slipped the clutches to death under heavy load. To stop this invisible destruction, you must immediately alter how you manage the transmission's factory controls. Never leave the truck in standard overdrive when pulling a load through stop-and-go traffic or up a grade below 50 miles per hour. Manually push the button on the end of your shifter stalk to disable overdrive. This simple action forces the factory PCM to alter its line pressure settings, increases shift firmness, prevents the transmission from hunting between gears, and keeps your engine RPM higher, which maximizes fluid flow through your transmission cooler. If you want to go a step further, look into an aftermarket valve body modification or a reputable electronic shift kit. This physically overrides Ford's soft shifting parameters, delivering crisp, instantaneous gear engagements that generate virtually zero slip heat, ensuring your transmission actually matches the legendary lifespan of the engine sitting in front of it. Now we have reached the absolute peak of Ford's deceptive engineering on the 7.3-liter Power Stroke platform. The previous settings we covered can cost you thousands in premature wear, but this final factory parameter is a psychological and mechanical trap that actively blindfolds you while your engine destroys itself. Number 1. The dummy dash gauges and deceptive PCM thermal buffering setting number 1 is the factory instrument cluster calibration, specifically the oil pressure and coolant temperature gauges resting right in front of your face on the dashboard. Ford designed and marketed these displays to give owners peace of mind, presenting them as precision monitoring instruments that track the vital lifeblood of your heavy-duty diesel engine. The factory documentation leads you to believe that if the needles are resting comfortably in the normal bracket, your engine is operating within safe, healthy parameters. This is an outright, calculated lie designed to protect Ford service departments from customer inquiries. And it is doing the exact opposite of protecting your motor. Let me expose the mechanical trickery happening behind that plastic lens. The factory oil pressure gauge is not a gauge at all. It is a glorified idiot light masquerading as an instrument. The sending unit on the engine block is a simple binary on-off switch calibrated to trigger at a measly 5 to 7 psi. The moment your engine builds just 6 psi of oil pressure, that switch closes, and the instrument cluster electronics command the needle to jump directly to the exact center of the normal range. Whether your engine is making a healthy 45 psi at hot cruise or a dangerously low 8 psi because your bearings are failing, the needle does not move a single millimeter. It sits perfectly still, completely fabricating a reality that everything is fine. The coolant and transmission temperature gauges use an equally deceptive strategy called PCM thermal buffering. Ford programmed the cluster software to keep the temperature needles pinned perfectly dead center across an incredibly wide, dangerous temperature spread. For example, the coolant needle will look completely identical whether your engine is running at an optimal 190 degrees Fahrenheit or screaming hot at 230 degrees. The factory logic deliberately dampens the needle's movement so everyday drivers don't panic when watching temperatures fluctuate under load. The gauge is hard-coded to remain stationary until the engine has already crossed the catastrophic overheat threshold of roughly 240 degrees Fahrenheit. The consequence of this deceptive setting is that by the time your factory dashboard gauge finally moves to warn you that the engine is overheating or losing oil pressure, the mechanical damage is already done. You are driving completely blind. I have stood next to trucks with completely cooked cylinder heads, warped blocks, and melted pistons where the owner swore to me the temperature gauge never went above normal until the motor locked up. You can run your high-pressure oil reservoir nearly bone dry from a massive HPOP leak. Drop your lubricating oil pressure to single digits at hot idle, and that lying dashboard needle will still sit there proudly telling you everything is perfect, while your rod bearings are being ground into metal paste. The solution to this engineering trap is to completely ignore your factory instrument cluster and install true mechanical or direct digital aftermarket gauges. You must tap a real sending unit into the oil filter housing to read actual live pounds per square inch of oil pressure. You need an independent, unbuffered probe in the cooling system and a dedicated thermocouple in the exhaust manifold to track your exhaust gas temperatures. Do not trust your million-mile engine to a 5 psi dummy switch programmed by corporate accountants to keep you compliant and uninformed. Conclusion. Taking control of the million-mile engine, the 7.3-liter Power Stroke diesel earned its legendary reputation because the foundational iron sourced from Navistar is inherently unkillable. But as a veteran technician, I can tell you that it survived in spite of Ford's factory settings, not because of them. When you eliminate these engineered blind spots, when you stop running your oil past its shear life, stop letting your electrical system drown in extended glow plug cycles, override the soft shifting transmission logic, and pull off the corporate blindfold by installing real gauges, you shift from being a passive driver to an empowered owner. You don't need a $90,000 showroom truck with a fragile, emissions-choked motor that will leave you stranded at the first sensor glitch. You just need to apply real-world mechanical knowledge to the legendary iron you already have. Stop letting outdated factory manuals and corporate compromises dictate the lifespan of your vehicle. Treat the machine with the mechanical respect its engineering deserves. Fix what the factory neglected, and that truck will outlast any modern piece of plastic on the road today. Take control of your maintenance, watch your real numbers, and keep those trucks on the asphalt where they belong.